Hello and welcome. Thanks for choosing the driest track architecture. I'm the only thing between you and lunch. I'm Dominik. I'm from Accenture Vienna. So with every Red Bull you drink, you support the Austrian economy. We're not doing well right now, so please help us. I'm an architect. I'm doing that since 17 years. I have quite a few certifications and stuff. This is me waiting for the kids that are jumping around somewhere at IKEA. So, yeah. Today, and so the clickbaity title worked. ChatGPT has to be thanked for that. Today, I'm going to bore you to death with processes. But I want to conceive the message essentially that those things are important even if we want to get rid of them and we find them nasty as engineers and they kind of stand in our way. So this is roughly what we're going to do. What is a process? How did we do it in the past, right? So I'm going to talk about how we did it in a traditional monolith. I'm going to talk about how we did it in SOA-land. I don't know who here remembers SOA-land. We're going to do it in microservices and REST, and we're going to do it in the coolest way, event-driven one, and then wonder why that can't possibly be the right way to do it. So, say hello to our totally harmless process. This one is taken from insurance, but I could give you a gazillion of different processes. And this one is, it has been dumped down significantly, like really significantly, but rest assured, every company of a certain size with department and stuff has processes. So what do we have here? Process starts, so we have some kind of insurance sales process. So you essentially got an offer, want to throw it into the system. So the first thing we do is we reserve a policy number, right? Why do we do that? Because every proper insurance has some legacy craft and probably some different insurance systems, but they want to have one policy number that is valid everywhere. So we have to reserve that thing. Then we have to execute some discount checks. So we are talking about the traditional insurance. Please don't take the first price, do some haggling. There's always some room, right? But depending on whom you're talking to, he can give you more or less discounts. And if he wants to do more discounts, he has to run through a process. So if the discount check is fine, then we can run some additional business rules. And then finally, create the insurance in the core system. If that first part didn't work, we need some manual check by some higher up. That depends a lot, like where are you buying it, how do all the rules work, it depends on the product, da-da-da-da-da. If it's a no, this poor guy has to go back to the customer. That's the moment when he tries to sell you a new package that is much better, right? The reality is he didn't get the rebate that he wanted. But anyways, right? So this is our totally harmless process. It's easy, right? You can see it's reserve policy, then execute discount. If yes, run business rule. If no, do the manual check. This thing comes back, call core insurance system, we're done. That's like 7 lines of code. Perfect. The trouble is, it's not that easy. Right? So those agents are not terribly disciplined. So they could be doing multiple offers in parallel, right, to essentially test the waters, like how much rebate can I give, how much can I not give, so they do it in parallel. So we reserve policy numbers like hell, because why would he cancel the thing? So what do we do about those policy numbers? Do we give them back? Some kind of external thing, right? Yeah. So those rules about discount rules, they change, right? And if they have a lot of manual processes, it makes sense to adapt the rules. So do you need to rerun in-transit requests that are currently in the manual queue when the rules change? Right? That would simplify because then the queue gets shorter, but then you need to rerun it. Then the business rules, of course, they also change all the time, and you have to call a range of unreliable systems, right? Or systems that are a bit nasty, right? So for example, if you do a car insurance, like every proper country has some central registry, those central registries, they have interesting APIs. They have interesting availabilities, interesting performance characteristics. And then in the end, we sent that stuff into our totally legacy insurance core system, which is not available 24/7, needs some throttling, has some very slow response times, and so on and so forth. And yeah. And if it doesn't work at all, how do we roll all that stuff back? And then the worst one in yellow, the freaking customer calls and actually wants to know what's up with his insurance. So how do we know that? So that's what we expect from a process, roughly, right? There's even more. And then there's this interesting concept of ownership, right? We know that in software engineering, it will work better if it's like the famous Amazon pizza team. Right? So if we have a pizza team, that will work. The problem is this is multiple pizza teams. So the reserve the policy numbers, it's some central foo, right? It's rather technical. That one won't be that hard. The discount checks, that's sales departments. Those are people that talk a lot. It's a lot of different people, right? So aligning with that is a bit tricky. Like who's the IT group for that, right? The manual checkup, again, very, very nasty. Depends on the department. If you're with an Austrian insurance, it depends on in which place of the countryside you are. If you're with one of the big German ones, it's convoluted, let's say the least. The business rules depend on the different insurance types, so that the kinds of things that you actually want to insure, completely different departments, different building, different place in the city, you don't know, right? It's not like you can co-locate them with the same pizza team. And then, of course, you have multiple insurance types in one system, but of course, you have multiple insurances. The key here is, this is most probably, in real life, never going to be this one team that has everything under control. So it's not easy. But we still want agility, right? We still want speed. We still want to change and adapt those rules quickly. We still want all those capabilities. So you're in the architecture track, so we're going to evaluate things on some criteria. So we're going to look at ownership, we're going to look at multi-team scalability, we'll look at agility, DevOps, like in general, like how quickly can we do changes, operability, technical scalability, and finally, of course, process transparency and control. You know, client calls, you want to know where the process is? We should know where the process is. We should be able to look it up. So how did we do that in the traditional monolith? And why do the business people actually find that kind of good? Easy, right? Traditional monolith, right? Be it on a mainframe, then you call it modules, or be it in smaller companies, right? Let's assume you have a smaller company and you just do it in Ruby on Rails. It's all just at one place, right? It's very, very easy because your process is actually code. You can just call those different components. They are on the same system. And everything is right there, including queues, if you want to do a little bit of async, there's batch jobs, if you want to do a little bit of mass processing. Everything is under one transaction manager. That's pretty cool, because that means that if you reserve a policy number and in the next step you realize that the discount check doesn't work out or it fails somewhere, you can hand back that freaking policy number and just get a new one later, because it's under one transaction, right? So it's really easy to understand. The key, of course, to not end up in utter chaos, right, like spaghetti code and so on, is the key lies in good modularization and discipline. We're, of course, not very good in that, but anyways. So, quickly. Ownership. It's a bit of a mess, right? Traditionally, we have total separation between dev and ops. But at least it's a handful of people that dance around in that system. Multi-team scalability, super, super, super hard, right? There's a reason why we moved away from monoliths, right? So sometimes you don't have multiple monoliths, but that's not great, right? Agile DevOps doesn't exist, right? There's processes, right? You get into a queue. We want to go live, we want to go productive. On mainframes, you usually have quarterly release cycles, so that's not really great for changing business rules, right? Operability, pretty good. Technical scalability, expensive like hell, but it scales. The process, well, it's visible, right? It's in the DB. If you want to do some automatic retries and that kind of stuff, right, you have to build that control into the software. Done. So pretty fair. But the agility, once you get big, breaks. This is not an option for a big insurance, right? If you're Moderately big with a few departments, this falls apart, right? And yeah. So, SOA. Who here anyway remembers SOA? Oh, fantastic. So we're in the land of application servers. So service-oriented architecture was a really fun exercise. So you have a real separation of services. That's like a total innovation. So you can actually give different teams different services. Everything runs in application servers. Those application servers, of course, are expensive. But they provide you databases, they provide you queues, they provide you a directory, they provide you something lovely. XA transactions. The slowest thing under the earth. But essentially, it simulates one big machine, as long as everything runs fine. If anyone here in the room ever had a transaction hang up and essentially crash the WebSphere or WebLogic server, and the only left state is there on the disk, great fun, right? But as long as it works, it kind of works, right? But the cool thing is you can lock between servers and it's fantastic. But you have a consistent environment. That's good, right? So you have a beautiful concept. You have a clear labor division, but it's woefully complicated also on the operations side. And now something very interesting happened here, right? Because we now suddenly, in contrast to the monoliths, we splitted up the responsibilities, right? So the process in green, we put that as a process on our BPM server, right? A proper BPM server with its own BPM team. It's an expert group of BPM, right? You call them. They are closer to business. They're not in your building. They're in the cool building. And then the services that are called, that are orchestrated in the thing, right, are also owned by different teams, right? And they're on different servers, but it's all transparent, right? You surely remember Corba and RMI and EGBs and that kind of stuff. You can call them, right? So now we separated things. What does that mean? So ownership suddenly got a little bit more nuanced, so I needed 3 bullets for that. So the services are scaled across teams. The process ownership is with a different team. And the ops is totally separate, right? Everyone who has seen SOA remembers the local environment is just never like the production environment. Never. It just isn't, right? And you need to talk to the operations people to get some stuff configured in the WebSphere or WebLogic or whatever you use, right? So we now have multi-team scalability. We gained that. We can put more developers on that thing. And that's a big success of SOA, right? Agility and DevOps is totally fucked up because essentially it's throwing EF files over the fence and hoping that they work in the configuration that you have no insight into. Technical scalability is limited. You can throw money at it, but it's typically at least not as expensive as the mainframe. But something else is interesting. We now have a proper BPM engine, so the process has excellent visibility and control. If you want to know, if the customer calls or you want to rerun something, you see all those process instances in your BPM engine of choice, and you can actually control them, right? But it's the BPM team that does that. It's not the developers. It's a different team, right? So that's how SOA did it. Now, I think, and it's unclear, right, but SOA wasn't really a success story in the end. And the big thing is essentially that the agility wasn't there, that the separation between operations and development on an application server level just wasn't a very successful model. And that's why many say that microservices, right, with REST and so on and so forth, is actually SOA done right, right? Because it's still service-oriented. We have services. They are now called microservices, right? So we have a real separation of services in this scenario, and everything runs in a VM or nowadays a container. It's always important to remember that originally that stuff started with VMs, right? Whoever started with the initial Netflix stack, right, remembers that was all VMs. Right? They built a VM image and then they deployed that. We have a very clear ownership of data. That's totally new, right? So the data is no longer with a central database team. I forgot to mention that. It's no longer with a central database management team. It's now with each individual thing and have a typo in there and everything else as well, right? We have concepts suddenly, right? We have domain-driven design, right? There's this famous book from Eric Evans, I think it came out 2004, 5, something like that, 3, I still have it. DevOps comes and finally, dev behaves like production. And that's a total boon for productivity, right? Now the world here is great, right? It looks all beautiful, like really beautiful, if it weren't those other nasty services. So you're in a team, you're with your microservice, you have everything under control, but you have to call all these other services. Some are slow, some are quick, some do what you expect them to do, some don't. You have to talk to the other team. It's hard, right? And then comes business, and they understand that microservices are cool, but what business doesn't understand, that it's suddenly no longer one transaction. So we came up with very fancy stuff. We came up with the saga pattern, which is just a very nice terminology for a compensation transaction or rolling back in some way, right? Everything you move forward, you have to move back in the case of an error. We came up with chaos monkey testing. We came up with concepts like circuit breakers, right? To get some reliability and consistency into that system. And because everyone can update and do stuff independently, and usually those things are not done in monorepos, we have things like Pact to do contract testing, right? Because no one really owns the entire system, right? Really no one does. Now cool shops like Spotify and so on solve that to a certain degree, right? They have the terminology around it. You have tribes and so on and so forth. And that kind of brings an order into which you need for this process, because this freaking process, it doesn't behave like we want. It's still end-to-end. So in this case, we, again, just like in DDD, we have this split up instances, but now we have a real separation in the implementation. So in contrast to SOA, we no longer have a consistency in the way microservice A, B, and C actually operate. They could do things very, very differently. So whereas in SOA everything is very, very uniform, in microservices that becomes a completely different thing. Because you have those old microservices that were still running on Tomcat, and you have the new ones that are actually on Spring Boot, and so on and so forth, right? So stuff is now separated. The teams have to work together to make a process work, which is a little bit painful. That's why Pact and all that stuff comes in, because they can behave separately, right? And there's no real standard. So either you have something like an embedded process engine, like for example Camunda 7 or before, right? Or I bet with you that they hand-programmed something that essentially is a process engine, right? In every seriously big microservice architecture, you will find a ton of state machines and a ton of process engines somehow coordinating that over the database, and no one knows about it, right? And the harder it is to do a process the right way, right? And especially BPM is a very, very, very hard pill to digest as a developer. The more you will get that stuff implicitly somewhere in the code, because it's like, oh, let's just do an if and we're done, right? So how do we fare? Ownership, excellence. We had end-to-end ownership of the individual services with real DevOps, with excellent multi-team scalability. So microservices is really a story of success. It's the architecture of the web, so to say, right? Operability is solid per microservice, but system-wide, it's always a little bit tricky. Like, how do you ensure that all of that stuff works together? And I'm mentioning this because that's critical from our process view, right? So technically, we're now practically infinitely scalable, right? In that time, also NoSQL and all of that stuff came up. So the individual microservice can be fast as hell. Of course, if you have an embedded BPM engine in there, and sorry again to mention Camunda, it will run against the relational database, and the relational database will have limits. And we're talking a few hundred of new process invocations per second. So that's a pretty tough limit, right? So the process is either self-built, where you don't know the performance characteristics until you really tested it, or it's an embedded engine, right? So, still people were not totally happy with that. And I would already argue that the process situations has worsened. So we are now better in implementing, we are now quicker, but the process situation worsened. But it got even better. Because then, what's better than a microservice you have, another team's microservice where you have to deal with their responses? What's better if you don't have to deal with the responses, right? So in came the event-driven microservice. And what we do now is that we take decoupling to the maximum, right? And what we essentially now do, and now the picture looks way more beautiful, right? Because it's no longer chaotic errors. Everyone talks in an ordered way to Kafka, essentially, right? So we talk to Kafka, we receive to Kafka, we send around events. Right? And there's a formidable debate, especially also with more experienced architectures, whether those are really events or it's not really messages and a command reply pattern. But let's stay away from that. So we have microservices. The microservices send events, and Kafka enters the scene because Kafka essentially suddenly made the scalability-wise very limited messaging queues, the transactional ones. It suddenly provided nearly unlimited scalability, right? And suddenly you no longer have to deal with those nasty services because you just put an event on the topic and you're done. Right? You're done. And you just receive events and you send around events. But what now happened is that the process disappeared completely. It is no longer visible because the process now relies on some start thing happening, and microservice C saying, oh yeah, I'm now reserving a policy number, and then sending out a message. I don't know, so we send out a message, we have reserved a policy number, we probably have to say for what, because somehow the blue box, execute discount checks, needs to pick that up and do something with it, right? And so it goes on. Right? And they send around events, they're perfectly decoupled, they can scale perfectly, right? But we're in choreography now, and yeah, everybody needs to know what to do. But it's really, really hard to know what actually happens, right? So ownership, again, perfect. Every team owns its thing, right? It's just, yeah, overall complicated. The multi-team scalability is excellent. It's better than ever, right? Because we just send out events, right? Agility DevOps, excellent per microservice. Operability, again, solid per microservice, system-wide, a bit of a difficult story. Technical scalability is practically infinite, and if you haven't built anything for it, your entire process world is shit. A, you don't know where an individual process is, because you have to ask and scan through Kafka. And B, you cannot control anything. Remember, so A, customer calls, wants to know where his process is. We don't know. Variant B, we change something, we want to rerun some stuff or retry some stuff. Well, we can't unless we build something for it, right? So this is a really, really, really hard thing. It's like solving a mystery without clues. I've seen teams, right? And I've been in such system. I've seen teams like spend days digging through Kafka and log messages because the worst thing that happens in those systems is some service consumes the actual message but then doesn't do anything. And you don't see that, right? Because it has been consumed, the consumer pointer moved further, there's no error log, because something happened, you don't know. So the digging starts. So while events are perfect in native situations, like IoT situations, logistics, payment systems, for example, they might not be so perfect for cross-domain, nitty-gritty business processes, right? So what can we do about it? And what's wrong with pure choreography? Because technically there's nothing wrong with it. And I already said it, it's like the debugging is like solving a mystery without clues. You just don't know, you just start searching. You don't have this process transparency unless you build it, right? And there are products now out there that somehow, if your messages conform to something, use some AI to essentially say, okay, typically if that happens, then that happens. And so maybe that is a deviation, right? But that's not exactly what insurance folks understand under process control. You have no central control to rerun, retry, or whatever, unless you build it. And the funny thing is, while we're still doing that in the enterprise, everyone else kind of realized that. Right? If you search for Uber, Netflix, LinkedIn, Airbnb, and the likes, and you add workflows or something like that, you will find out they stepped into the same funny problem. Right? They went down the train into pure choreography on all levels, because I'm not saying it's totally wrong, it's just like, for what do you use the tool? And then they realized, well, it's not that great. Because what we actually want is we want some kind of orchestration. We want to have some control over stuff. We want to do what business actually thinks is a good idea, and which probably makes us money. But we want it to fit into modern team topologies, right? It shouldn't be the strange central team which has a different release cycle and that I have to wait upon, right? It should fit with real DevOps. There shouldn't be a slowdown. We want high throughput, and it should be cloud native, whatever precisely that means, but in the end means it's a proper distributed system you can rely on with proper HA characteristics and so on. So something you can trust and that you can build upon. And the interesting thing is, those guys essentially went onto the market after going into full swing with choreography and then decided, boy, we got to do something about it. And then they self-built it, right? So Uber came up with Cadence. The Cadence folks at Uber, essentially quite a few of them left Uber, then built their own company, and there's Temporal. So Temporal is a code-based orchestration engine, so you write workflow functions as ever in your TypeScript, in your Java, whatever. And then you have actions, and it will make sure that it reruns. And often, it will make sure that it runs, and either it's backed by a relational database, or you use the cloud service, or you use Cassandra, or whatever, it scales, right? That one is still open source in its core functionality. Netflix came up with Conductor, which was archived in 2023 because already a lot of other forks essentially gained popularity. There's right now Orcas, but I understand it's not closed source. The Airbnb approach went into Apache Airflow, which is a little bit more visual. You can do it code-based, but it can also do the visual thing. Camunda essentially rebuilt their entire BPM stack, right? It's no longer an embedded engine with the open source ZB project, and then came up with Camunda 8. They kind of rebuilt Kafka, so it's a very performance solution under the hood. It's BPM, right? In insurance, that's popular. In other places, it's not so much. I think your orchestration solution needs to fit the people that you have. If you are code-centric, you need a code-centric solution like Temporal, like others that we have here. Durable functions, for example, from Azure is very similar to Temporal. Also how it works under the hood. The Flink guys, stream processing, it's an alternative to Spark. They are now doing Restate. It just recently went into 1.0. It's also a workflow engine. They call it durable execution. Sounds more positive, right? But it's in the end about just that, right? You want to reliably execute something and have control over it and do that in a scalable way. And of course, we have the cloud providers, durable functions from Azure, code-based, AWS step functions. It's declarative. You have a visualization. The solution from Google also does have a visualization, right? And people can do it in that way, right? Now the question, of course, is, does that mean that events and event-driven is all for nothing? No, I don't think so, right? Because I think the event, a policy number has been reserved, is utterly useless, right? An event that some discount checks have been executed on something that could potentially be a policy, it's not very interesting, right? But what is interesting on a company-wide level and where events really shine is on a higher enterprise-wide level, like, oh, an insurance policy has been created. That's a proper event. It's enterprise-wide. There's no compensating transaction, right? Because that policy is now out there. It's valid, it's signed, it's stamped, and as long as the customer pays, it is valid, right? And it is a truly relevant event, and it's probably the starting point for a lot of other things. The marketing department can now start bombing you with advertising. The CRM department can essentially send you account and access data to the online insurance something, right? So there's a lot of things that can suddenly happen, right? The data warehouse can pick it up and can say, okay, let's roll up the reporting. It's useful. It's a proper event where others will react to it. The others, not so much. And I think that's my key takeaway for this entire thing, right? We came up with event-driven, and it was a huge improvement for the situation of endless REST chains, and if something broke down there, you had a real problem. But it's not the solution, of course, depending on the specific use case, that universally works until the lowest level. Right? Because testing that stuff and working with it is really, really, really hard. And again, as mentioned, there's exceptions. Payment engines, perfect. Logistical backbones, perfect, right? But not for everything. So thank you. Are there any questions, or do you want to beat the queue?
We've got at least one question so far, so I thought that everything is clear, but then one question came. Are there tools which will just monitor your topics for events and update the state of your business process just to improve the visibility over the BB? Oh, I was wrong. There are so many questions.
So I think Solace can do that, or that's at least what I heard from quite a few colleagues. And you would need to standardize your events on something. So if you essentially say, okay, I apply cloud events and use that as a standard, then already tools can start reading that. But I don't know of a really, really good one. Can I go down there? Then I can read that stuff. So what else?
Isn't it this new orchestration wave kind of different take on Saga pattern?
In a certain sense, yes. So you have a workflow function, right? And if an action, so something with a side effect, which did a transaction or something like that, like we reserved our policy number, right? If that happened and you realize you cannot move forward, although the workflow engine will give you everything to retry and retry and retry and do that for weeks, right? But if at a certain point you say, no, we're backing out, yeah, then you have to do something. Either you have to kick the reservation or you say, I don't care, but it's well organized in one block of code. And if you realize that thing has a bug, you can change it, right? Because it's still state, right? It's still a running process. So I would argue it makes it a little bit easier to handle. So
how can be used Camunda, Airflow, etc. to orchestrate event-driven services?
There's a lot of write-up about that. Many of the systems can totally fine consume events and then essentially create new ones. You still have a little bit the problem that you don't get any kind of immediate feedback, right? So you send out an event and then your process continues when you receive a specific event, and then you wait. And after 5 minutes, there's no event, probably fine. After a day, there is no event. Should you send the original event again? What should you do? So it makes it a little bit trickier. But the integration, of course, is better because foundationally the systems can handle the load and the scale that comes with those things. Are there any
BPMN tools that you recommend?
I only know Camunda. That one I know very well. And it's okay.
So what do you suggest in the wise combination of orchestration and choreography?
Well, as already mentioned, and don't want to drain it too much, I think we should critically think about what is an event that is truly of interest to others, right? If it's actually a process and I actually only expect one specific entity to do something, it's probably not. So in a DDD sense, I would look at on which level are we playing, right? If we're really across a lot on a very broad scale and we're fanning out the thing, an event is fine. Like, okay, we have a new policy, we have a new customer changed his address, whatever. Those are interesting events for the rest of the world. If there is something strictly required in a specific situation, right, and there's a real business flow, I would go towards orchestration, because typically your business expects you to answer questions and to answer the question, what happened with this and that, right? If marketing department didn't pick up on the new address, that's not that bad. If it's something regulatory, it gets interesting, right?
If assuming everything in a system belongs to some team or domain in the DDD world, where does the orchestra belong to?
So the workflow itself has to be team owned, right? And you need to clarify with business how that is. And I think that is the dramatic change between this old model with a central team and a central BPM engine, just in the same vein that in the past we had the database administrator team. I don't know if you remember that. You could only issue SQLs that were green lighted by your database administration team, right? The beauty here is you write the workflow engine, you write the workflow code, or you have the BPM, you submit it to your workflow engine, it's under your control. So there is one team that needs to be responsible for it. Otherwise it doesn't fly. But it's two different things, right? One part is the technical infrastructure of an orchestrator, just like the technical infrastructure of Kafka or the technical infrastructure of a database, and the other thing is what you put inside of it. And that should be with a team. Right? The rest for me is kind of a platform service.
Why can't we use events with orchestration?
I think we drained that. So in a lot of those systems under the hood, it's events, right? ZB, the way that Camunda 8 is built, sends around a ton of events, right? But then it tries to give you consistency on top of that. If you send out an event, that's totally fine. As said, you don't have any guarantee that the other side actually processed it. So suddenly you're looking at timing. And timing is never the best control mechanism, right? So sometimes it's just easier to make a proper call.
As for timing, I think it will be the last question.
Yep.
Why don't we develop a new framework that can fill the gaps in choreography?
You can. You can, and I think that is what is happening with cloud events, that you at least standardize what you put into the event, and then you could put some description over it where you essentially say, okay, I expect this type to come first, and then I expect this type to come after, and then you could build it. On top of it. But I don't see a dramatic conceptual difference between an orchestration system that uses events under the hood and gives you a really nice interface, and you dealing with events that then have to conform to a very specific situation so that another system can pick it up and essentially give you the proper visualization and control. Because both sides need to know about each other in some way. So suddenly you have some kind of implicit contract. That's why you would need a framework, yeah. Which again would limit you, because then you would call the framework, right? And the framework would put the message or the event on the bus. But hey,
yep.
Thank you.
Thank you very much.
It's lunchtime.
Yeah, exactly. Thank you very much, Dominik.